Viscosity is just the resistance to flow in a liquid. And just to give a flavor of different viscosities, if we were to look at 25 degrees C and 1 bar, let's just compare a couple of liquids. So the SI unit for viscosity is the Pascal second. We're going to use millipascals because for most substances the viscosity is much lower than a Pascal second. So here's some different materials. We've got water, we've got ethylene glycol, and then glycerol. And we can see as we get to liquids that you just think of intuitively as being more thick, the viscosity goes up. So it's much more difficult to drag something through glycerol than, say, water. If we're trying to move a spherical particle through a viscous liquid, we find that the force of drag is going to be proportional to the viscosity and also the speed at which we're dragging it through the liquid. So if we're moving to the right, we're going to have a drag force to the left. That's what the minus sign means. And this is for spherical particles of radius r. So this is only true if we have laminar flow. And that's what you will get if you go through if you drag this particle through a viscous liquid at low speed. And the speeds we're going to be dealing with in electrokinetics are all going to be low speed. So we're going to get laminar flow. In electrokinetics, we're going to be applying potentials across a distance, generating electrical fields, making things that are charged move and thus inducing a current. And so in all these things, it's useful to know the SI units. So the first, just to remind you, is an amp. And an amp is just the number of coulombs per second. One that you're probably less familiar with is a Siemens, and that is make sure you know that it's a capital S so you don't confuse it with seconds. And that's conductivity. And so Siemens is just going to be equal to the number of amps you get for a given voltage difference. So the more current you get for a given voltage, the higher your conductivity is. And there's a volt with symbol V. We use a different V just to keep it distinct from velocity. And that's going to be joules per coulomb. So in other words, if I take 1 coulomb of charge and I move it through a potential difference of 1 volt, that's going to be 1 joule of work. And finally, electric field. And electric field actually has 2 different types of units. You could say that it's a Newton per coulomb. In other words, how much force it takes to push a coulomb of charge is giving you a measure of how strong the electric field is, or you could just as well say that it's a volt per meter. So if I have a certain voltage difference, and that certain voltage distance is a certain distance apart, those 2 numbers tell me how strong the electric field is. You're going to need all these units, be able to manipulate these units to be able to check and cancel your units in electrokinetics.